Hello viewers, welcome back to Math in Motion. This is Shaka Anwar, your math tutor. Today, I think we're going to be enjoying stochastic processes as I promised last time. And then today we'll talk about the heating probabilities. Members, today let us see how we go about the heating probabilities. Here we shall mainly find the probabilities of reaching state J from state I for the first time. And if state J is an observation state, then we shall call that probability to be the absorption probability. I'm saying that recall that we may have probability of now if I'm in state J, like probability of being in state J given I'm in state coming from state I, like x not equal to I. This is what we call the transition probability at the start. And then this is what will be the n transition probability, because the difference between n and 0 is n. So n minus 0 is n. But now today we shall need to get like the probability. We shall let, so if we let H I A be the probability, yes, of hitting or reaching state A, of hitting state A from state I, for the first time. And then we know that our states, our S, 0 should be contained. I have state 1, 2, up to n. Therefore, the probability of me coming from, reaching state A, which state A is given, but I'm from a given state, like x not equal to I. So that this is the same thing as having the summation, as we call, probability of xn contained in A. Yes. Now, given, if I try to expand this, I have now x1 equal to k times probability of now x1 equal to k. Yes, given x naught equal to I. I think because these steps I'm doing now, Markov chains we saw last time. Then this is a property of Markov chain. I'll have something like this. But now this k will run for all s. Like this k is contained in s. Remember, our s is a set of finite states, like 1, 2, 3 states. Now from here, I can easily say that this is the same thing as having. Remember, this is the same thing as having summation from k contained in s. Yes. Now I'm hitting state A from k. This is the same thing as having probability of hitting state k. Yes. Probability of hitting state A from k. It's k A. Now times that's the probability of coming from state I to state k. Probability of coming from state I to state k. I can easily write it as the format, in this format, like summation for all k contained in s. Now probability of coming from I to k times the probability of hitting state I. So probability of hitting state A from k. I think we are together, and I think we shall get its meaning properly when we are doing an example. Here we may have like two. Okay, let me just give a simple example. We may have like two states, like state 1, state 2, state 3. If they ask me what's the probability of me hitting state 3 from state 1, what's going to be the probability? It's going to be the same as I'll first move from k from 2 to 1, and then I now look at me coming from 1 to 3. Like this is that's the meaning I'm trying to give. Shall we get this meaning properly? Now we are doing the example. I'm saying that the hitting probability of me coming from state I to state A for the first time is the same thing as having probability from coming from state I to a given state k. I'm coming from 2 to 1, then times the hitting probability from state 1 to 3. And then this is going to be our formula we're going to apply for every question that asks us to find the hitting probabilities. Likewise, I can summarize my hitting probability. I'll say that now. Therefore, my H, if I'm given like, I want to summarize the equation to be in this format. It's going to be the same thing as having like my H, I'm coming from I to k. It's going to be the same thing as having, I'll always have 1 if I is the same as, like I is the same as A. if I'm moving from one state to that given state, if I'm hitting that state from, like, if I'm hitting state 3, from state 3, the probability is going to be 1, because I'll be just in the same state. And then I want to be always summating the probability of coming from state I to state K. So the probability of IK times the hitting probability from that K state to state A, when K is contained in S, but when K is not equal to I. This is going to be our formula for the hitting probabilities. Now I think from there we can do an example and we see how we can apply this definition of ours to a given example. Now from there, I think if we try to do an example, our example will be like, if I do an example, we shall say that our example, we may just define a simple transition graph. Like we have 4 states, like state 1, state 2, state 3, then state 4. You are saying that the probability of me coming from 1 to 2 is 0.5. The probability of me coming from 1 to 1 is 1. Then the probability of me coming from 2 to 3 is 0.5. The probability of me coming from 3 to 2 is 0.5. And the probability of coming from 3 to 4 is 0.5. And then the probability of me coming from 4 to 1 is 1. And then our question is saying, let us find what's the hitting probability of state 4 from a given state I. Question is saying, what is the hitting probability? Probability of hitting state 4, of hitting 4 from I for the first time. Now from there, I think we can easily now answer our questions. Now remember, we've said that one find the hitting probability of me reaching state 4 coming from state I for the first time. As we agree that me coming from state I, say 1 to 4, me coming from 1 to 4 is going to be impossible, because 1 is an abstraction state. I cannot go from 1 I cannot go from 1 to 4 if I'm at 1. Therefore, its probability is going to be 0. I'm coming from 1 to 4 is going to be 0. And then coming from 4 to 4. Remember, I'm at 4. Now reaching at 4, the probability is going to be 1. Because being at 4 when I'm at 4 is going to be 1. I think we are clear also that step. Now for that step, I can say, what's the hitting probability H from 2 to 4? I want to go to 4. I want to go to 4 from 2. We say that this is the same thing as having the probability of me leaving 2 to 1. This is 0.5. Yes. I'm leaving 2 to 1. Then times the hitting probability from 1 to 4. Yes. Now plus the probability of me staying at 2, which is 0, times the hitting probability from 2 to 4. Because the probability of me staying at 0 is 0, because there's nothing like analog at 0, staying at 2. Also, now plus the probability of me leaving 2 to 3 is 0.5 times the hitting probability from 3 to 4. And therefore my H24 going to be the same thing as having, remember, the hitting probability from 1 to 4 is going to be 0. Then this is 0, we're going to have 0.5 H34. And that's my question 1. Now, first find the probability of hitting 4 from 3. Same thing as having, I'm 3. I first look at probability of me going to 2. So it will be 0.5. H now from 2 to 4. Now plus, me staying at 3 is 0. 0 H34. Now plus, me going to 4 is going to be 0.5 times H4. Like the hitting probability from 4 to 5. Now from there, I just say that my H34, which will be the same thing as having, because H24 we don't know, this is 0.H24. Yes. Now plus 0, then plus 0.5 times 1, because say the heating probability from 4 to 4 is going to be 1. And then this is equation 2. Now, if we try to solve equation 1 and equation 2 simultaneously, we shall be able to get our H24 and H34. Like, if we try to solve our equations 1 and 2 simultaneously, we shall be able to get H1, H24, and H34. Now, from there, I think we have calculators and we shall be able to solve this question. Like, if I place where there is H24 with this value of H23, therefore I will say that my H34 equals to now 0. This is 0.5. Sorry, this is 0.5. This is 0.5. I have 0.5 into H24 is 0.5 H. Yes, 0.5 H34. Yes, H34. Then plus 1. Then I have H34. Then I think 0.5 times 0.5 is 0.25. 0.25 H34 plus 1. Then if I have this side, I have 0.75 H34, which is the same as having 1. Then I have my H34 as I think 3/4. I don't recall. What is 1 divided by 0. What is 1 divided by 0. 1 divided by 0.75 is going to be 3. It's going to be 1. So okay, 1 divided by 0.75. What's the answer here? If you press your calculators, it's going to be 2/3. This is the same as having 2/3. Now from there, we can easily now get our H24, which is the same thing as having 0.5 times that one. Yes, which will be a half times 2/3, the same as having a third. And therefore, our heating probabilities HIK, probabilities of heating A from I, the same thing as having probability of heating I from 1 is going to be 0. Then the probability of heating 4 from 1 is going to be 0. The probability of heating 4 from 2 is going to be a third. And then it will be 2/3 and then a 1. Then this is going to be our heating probabilities for this question. Now let us do another example, second example 2, and then we shall see that we are done with the heating probabilities. Yes, members, let us continue the example 2. Now example 2, we are given a transition graph. As you are seeing that the probability of me coming from 2 to 1 is 0.2, coming from 2 to 3 is 0.4, 3 to 2 is 0.3, 2 to 2 is 0.3, then 2 to 4 is 0.1, then 3 to 5 is 0.5, then 3 to 5 is 0.7, and then 3 to 1 is 1. Our question is typically saying that what is the transition probability of hitting state A? But now we don't have state A. But now we are saying if state A is 4 and 5, like we have to combine 4 and 5 to give us one state. Yes? We have to combine 4 and 5 to give us one state. Therefore, I have to redraw this diagram with the state A as 4 and 5. Like if I try to redraw this diagram, I'll have like a diagram like I'll have a 1 here, then I'll have a 2, then I'll have a 3. But remember now, state 4 and 5 are becoming state A. I have state A here. Now these values remain the same. From 2 to 1 is going to be 0.2. From 1 to 1 is going to be 0. It's going to be 1 as diagram. Now from 2 to 2 is going to be 0.3. Then from 2 to 3 is going to be 0.4. Then from 3 to 2 is going to be 0.2. But now state 4 and 5 have become one state, like 5 and 4 are becoming one state, state A. Now, what are the probabilities that are going to state A? We have this probability like coming from 2 to 4, which is 0.1. And then we have probability like 0.3 and 0.5. We are going to state 0.3 is coming to 4, 0.5 is coming to 5. Therefore, if we combine the states, therefore, shall need also to combine this probability. Like probability of 0.3 plus 0.5 is going to be 0.8. We are going to state A. And therefore, that becomes our new transition diagram. And now we want to get to know the heating probabilities. As we say that heating probabilities, first, if I not say that for me heating 4 from 1, like 1 to 4 is going to be 0. As you said that 1 is a transition, is a absorption state. I can't move from 1 to 4 because if I'm 1, I'm always at 1. Now again, my hitting probability from 4 to 4 is going to be the same as having 1. If I'm hitting A, this is not 4, this is A. Hitting A, this is hitting A. I'm hitting A now. When hitting A from 1 is going to be 0 because I'm not able to come from 1 to A. Then also me hitting A from 4. Me hitting A from A is going to be 1. And then now our task now is to look for H2A, H3A, and we see how we can get our answers. Yes, now if we begin with H2A, like I'm hitting A from 2. It's going to be the same as having me coming from 2 to 1, which is 0.2, times the probability H of me hitting from 1 to 4, hitting 4 from 1, so hitting A from 1. Now plus the probability of me staying at 2, which is 0.3, times the hitting probability of me hitting from 2 to 4, yes, 2 to A, not 4A. Now plus also the probability of me leaving 2 to 3, which is 0.4, times the hitting probability from 3 to A. I think on that step we are together. But now we know that H1A is 0 and H2A. Therefore, my H2A is going to be the same as having 0 here, then 0.3 H2A, then plus 0.3 H3A. Then from here, just if we just bring this inside, we shall have 0.7, 0.7 H2A like this, then minus 0.3. This is not 0. This is 0.4. 0.4 here, 0.4. Then minus 0.4 H3A equals to 0. This is our equation 1. I think members we are clear on that step. Now also now I'm at state 3 now. I want to get the hitting probabilities from 3 to 4, from 3 to A. Therefore my H3A is going to be the same as having the probability of me leaving 3 to 2 is going to be 0.2. Yes. The probability of me, probability of me leaving 3 to 2 is going to be 0.2. Now H2A, coming from 2 to 4. Another is going to be the probability of me leaving what? Sorry, I think we've made a mistake. Yes, okay. From here, okay, remember, let us repeat again and we see what we are doing right. Now from here, we are saying that we want to get our hitting probabilities. I want to get hitting probabilities from hitting probabilities. I want to hit A from 2. Hitting A from 2 means that I'll have to first leave 2 to 1, which is 0.2, times the hitting probability of 1 to A. Then plus also I will leave 2 to 3, which is 0.4, times the hitting probability of now 3 to A. Now plus again, I'm leaving 2 to 4, which is 0.1, yes, times the hitting probability, which is HA. I think that equation is clear. Also, plus the probability of me staying at 2, plus 0.3, me staying at 2, then plus times H2A. That's our first equation. The hitting probability from 2 to 4. I'm repeating, I'm coming again. I'm leaving 2 to 1 with a probability of 0.2. 0.2 and the hitting probability from 1 to A, which is this one. I'm leaving now 2 to 3, which is 0.4, times the hitting probability from 3 to A, which is this one. Now, plus again, I'm leaving 2 to 4, which is 0.1, times the hitting probability from A to A, yes. Now, I'm also leaving, I'm leaving 2 for 2, which is 0.3, times the hitting probability from 2 to A. Now, from there, we just know that where there is H1A is 0, where there is HAA is 1, is 1. Therefore, I say that my H2A is the same thing as having, this is going to be 0. Now 0.4 H3A. Now plus, this is going to be 1, which is 0.1. Then plus 0.3 H2A. A. Now from there, can just make 0.7. I'm just making 0.7 H2A minus 0.4 H3A equals to 0.1. My equation 1. I think let's say we are together. Now the next equation is going to be the heating probability. Yes. Now I want to hit. I think if I put off this, I think we are together. Now from here, right now I want to hit A from 3. Now if I'm at 3, H3A, yes, H3A, I want to reach A from 3. It's the same thing as me coming from 3 to 4, which is 0.2 H2A. I'm coming from 3 to 2, which is 0.2 times now hitting probability from 2 to A. Now plus again me coming from 3 to A, which is 0.8 H44. Coming from 3 HA44, like that. Now from there I shall be able to also make an equation like because I'm seeing H, yes, H44 is 1. Then I will say this is not 4, it is A. HAA, I'm at A. HAA is 1. Therefore I have H3A equals to 0.2 H2A, like that. And then from here we can be able to solve these two equations simultaneously. Then you get my answer. Now if I replace where there is sorry, this is yes, this is only 1. This is 1 here. 0.8 HAA, which is 1. That's a plus 0.8, like that. This is my equation 2. I'm saying now from here we shall be able to solve these two equations simultaneously, which is 0.7 H2A minus 0.4 H3A equals 0. This one, and then H3A. Okay, let me in their orders for us to enable us solve them using a calculator. This is negative 0.2 H2A plus H3A equals to 0.8, equation 2. Now if you solve them simultaneously, so you get to know that our H2A equals to what? Then H3A equals to what? Like if you place your calculators, what answer do you get? I personally got H2A as 21 over 31. 21 over 31. I think you have also to try and see whether you get the same answers. And then last I got 29 over 31 as my H20, 9 over 31 as my H3A. And therefore I will be able to say that my hitting probabilities, my HIA, is going to be the same thing as having me hitting A from 1 is going to be 0. Then me hitting A from 2 is going to be 21 over 31. Then me hitting A from 3 is going to be 29 over 31. And then me hitting A from A is going to be 1. And then this is going to be my hitting probabilities. Remember, I think for everything is clear in this video. Just thank you for watching. Like, subscribe, and share for more videos like this. And I will mention the math tutor. Now, I think we shall be doing the next video. I shall be talking about now the mean time or the arrival, like time taken for us to reach state A, any state A from a given state I. Thank you for watching. I remain Shaka Anwar, the math tutor.